Hello there, excuse me. Miss, hey, excuse me.
Oh my gosh, I'm so sorry. Sir, I didn't see you there. How can I help you?
I've got an appointment with Quinn.
An appointment with Quinn. Okay, what's your name?
Gadget, Inspector Gadget.
Inspector Gadget, okay. Hi, yeah, Quinn, I have a Mr. Gadget here to see you. Right, okay, great. So I'll probably just walk him back and we'll see you soon. Okay, bye. Okay, Mr. Gadget, just this way. I'll show you back to the shop where
Awesome.
Quinn is. Okay, great. Quinn, I have Mr. Gadget here to see
Quinn,
you.
it's so great to see you
It's
again.
good to see you again, Inspector.
Can I hang out for this appointment? I kind of want to see what he's picking up.
Yeah, of course.
Gotta be honest, Mr. Gadget. Word's been going around the office that you hired us to build you a helicopter upgrade, so I have to see how it works.
Yes, yes.
Is this what
This is what we're looking at on the test bench right now. It's a pretty cool system upgrade. So you're gonna now have the ability to fly,
Awesome.
which is quintessential to get to those inspection spots real quick.
That's what I need.
Yes. So you were here about a week ago and you saw a little bit of how it was gonna function. We've made a couple upgrades.
Yeah, what's new?
So it's a pneumatic and electronic system, and I'll show you a little bit of what we changed from last time since you did see a demo of it, but this goes up nice and quick.
Nice.
Deploys, the blades come out as well.
Wowzers.
Yeah, it's very quick. So a couple of things that we changed since last time, and you can see it is much quicker.
Yeah.
The blades no longer catch. It's a little bit more compact.
They look more aerodynamic
A
too.
little more aerodynamic. It's that 12,000 newtons.
Yeah.
Man. Gotta get you going real quick. I've fitted some of the alignment pins just a little bit more fixed, less tape, so you know, a little more skookum.
And is this something that Inspector Gadget's going to wear? Like, how does the harness?
Yeah, how does it integrate into my suit?
So you're gonna wear it on your back. It's gonna
Okay.
pop up through your stuff, and then when you're done with it, it will come back and be all compact and out of sight and out of mind.
And will this integrate into my current electrical system?
Yep. So it's actually running about 4 volts.
Yep.
So very little power. And pneumatic wise, we're about 20 psi. So
Perfect.
not a lot of energy usage at all.
Do you have any footage of you?
We
building it?
do.
You've been working on it for
We have. So why don't we cue that up and take a look at it, and you can see some of the steps to create some of the hardware and a little bit of the mounting and that kind of stuff.
Great, and then we'll
Sounds
try it
great.
on.
Awesome, sounds great.
Yeah.
So the very first thing we needed to test was to make sure that our blades would pop in and out of the tube nicely. Using Fusion 360 and some of our 3D printers, they came up with a hub that would hold the blades as well as slide up and down the tube appropriately. First thing you always want to do is bench test, so you're never going to stick it on a person to start with. Using simple things like tube as a shaft mounting. We use a desktop DC power supply as well as just a DC motor. Make sure everything fits nicely. Trying to do it as quick and dirty as possible to start with. Everything turned out fairly well, which you'll see coming up. Moving on from there, we're using, again, Fusion 360 to make the mounts for the blades. Those are going to be fiber laser cut out of sheet metal. Later iterations will be slightly longer, have a few more mounting points, and beveled edges to prevent them from catching as they come out of the tube. Here you can see laser cutting metal. Always be careful when working with hot parts. Try and use another tool. You can see me using my Leatherman to pick those up to start with. They turned out great. So now we're going to move over to the finger brake. Using this, we're going to make 2 90-degree bends to make sure that it fits properly and we can use it as a hinge. Those turned out great. So now we're going to move over to the wood shop to do our initial blade tests. Simply using some masonite, we're going to do a test length. They ended up being a little bit short. Later iterations, we made them a little bit longer. We're using masonite just because it's cheap, it's light, gets the job done for this particular iteration. Later on, it's going to be a PVC foam board that's laser cut to an exact shape, a little more blade, so it looks a little bit better as well. blades are done, so let's put it all together, see how it fits in the tube. Everything turned out pretty well. You can see I'm using a couple of pins here just to place those hinges onto the center hub. Everything spins nicely. Later iterations were a little bit longer. And then Inspector Gadget came for the final fit. What we didn't show was figuring out the human interface and mounting of the inner and outer tubes. Get the blades up and over Inspector Gadget, which is pneumatically driven. We just want to make sure he wasn't whacked in the head. After this test was, everything was ready to tidy up for final fit and finish for full Inspector Gadget integration.
It works.
Awesome.
Great build, Quinn. How did it feel?
This was great. It worked very well.
All right, so everything functions as it should. You got the controls down. You seem to have it all down packed.
Easy peasy.
Awesome.
Excellent work, Quinn, as always.
Thank you very much. Now that we know that it works on you and it fits well, why don't we test it out in the field?
Let's do it.
Awesome.
See you off.
Thank you.
This has been so great, Inspector Gadget.
Yeah, thank you so much.
Absolutely. Glad everything worked out.
We'll see you next time.
Bye.
Bye, Inspector Gadget. Come back soon. Safe flight.
Go Gadget helicopter. Woo! Bye, Quinn. Bye, Kim. See you next Halloween.